right, guys. 2.5 part 1. Does everybody have their notes pulled up? Everybody have their notes pulled up? Yes? Okay. This is the fundamental theorem of algebra. We're going to be doing a lot of algebra. We're going to be factoring. We're going to be using P over Q. We're going to be talking about real solutions versus imaginary ones. So it's going to be really, really important that you guys read the directions and answer the question how it's being asked. All right. We have talked about the fundamental theorem of algebra a little bit before. The highest exponent tells you what? The highest exponent in a polynomial tells you what? How many solutions you have. Okay, we're going to talk about linear factorization. All that means is, you guys will have, and we'll talk about this in a second, but you guys get a bunch of answers. Say you have like x plus 3, x minus 2, x plus 1, right? How would you get the zeros if you have these three factors? You set each equal to 0. So you have x equals -3, x equals 2, and x equals -1, right? Well, this right here is writing your answer as a product. What does the word product mean?
Answer of multiplication.
Answer of multiplication. So product means to multiply, and linear factors means these three are the linear factors. These are considered the zeros, the answers. The linear factors is like the step before you set it equal to 0. So if a question asks you to write as a product of linear factors, that means they want the parentheses before you set equal to 0. Does that make sense? All right. You have to pay attention, guys, to what I'm saying, because on your test, it's going to ask you to answer in specific ways. If you don't answer the right way, then it's going to be wrong. You can't come up to me and be like, did I do this right? That's what this whole test is telling you. Okay, so if we look at something like this, these are just basic examples. A first degree polynomial, x minus 2. How do you know that this is the first degree? What power is x to in letter A? It's the first power. It's just a linear function. All right. If we have a second degree polynomial, how do you know this is to the second degree? Because it's squared. How many answers would we have if we solved this? We'd have 2. If I factor this, guys, what times what gives me a +9 when I multiply, but a -6 when I add?
-3.
So x minus 3, x minus 3. How many zeros do I have here? 2. They both happen to be at what spot?
3.
X equals 3. So we say that this has what?
2 solutions.
It's 2 solutions, but if it's the same thing more than once, it's multiplicity, right? We're going to be talking about all this good stuff. Multiplicity. All right, a third degree polynomial. This is the third degree because it's raised to the third power. It's cubed. So if we were going to solve this one, x cubed plus 4x equals 0. Well, take out the what? Is there a GCF? Okay, x. I'm left with x squared plus 4 equals 0. Is x squared plus 4 one of those special patterns?
Yes.
No. X squared minus 4 is.
Oh.
Is x squared plus 4? No. If you set each of these equal to 0, x equals 0, x squared plus 4 equals 0, what happens when I solve this? You get an imaginary. 4 goes to the other side. So we take the square root. I have x equals plus or minus 2 what? 2i. You have 2 imaginary roots and 1 real one, right? This is all stuff you guys, we should remember this. What about if I factor d? What do I take out?
X squared and x cubed.
X cubed. I'm left with x squared plus 9. Real or imaginary?
Imaginary.
Yes. All right. X cubed equals 0. That's going to be real solutions. But x squared plus 9 equals 0. When I move 9 over, x squared is -9. When I take the square root, I get x equals what? Plus or minus 3i. I'd say at least a third of you forgot the plus or minus on some of your answers yesterday. I told you how important that was, guys. There's two answers there. It's plus and minus. Make sure you guys see that. All right, now we're going to talk about different wording. All right, a quadratic factor has no real zeros, are said to be prime, if it's irreducible over the reals. What that means is there's only imaginary solutions. Okay, we're going to talk about factoring over the reals and completely factored. So I want you guys to see the difference here. If you have this equation right here, they've already factored this for us. We're going to go through it. Do you see how you're left with x squared minus 5, x squared plus 4? Yes? This first parenthesis is real solutions. Agreed? All right, I move 5 to the other side, take the square root. Is it beautiful, pretty whole numbers? No, but they're real. This parenthesis has what? Imaginary solutions. All right, so you're going to be asked to factor and then write your answer in two different ways. If you notice here, really important, if it says to factor over the reals, what do you notice about the x squared plus 4 parenthesis?
It stays the same.
It stays the same. If you completely factor, what do?
U squared will.
If you completely factor, what did we do with the x squared plus 4? Do you see how when you factor over the reals, you do not break down the imaginary? If you completely factor, then you break down the imaginary. If they ask you for the actual zeros, they want the x equals, then it would be x equals negative root 5, x equals positive root 5. X equals negative 2i, x equals positive 2i. But when you factor and leave in factored form, if it's over the reals, if you have an imaginary, you leave it in an unfactored state. If it says completely factor, that means you break everything down. So it's really important that we answer the question that is asked. All right, when we factor, when it says to factor, you're going to leave your parentheses. If it says to solve, or what are the x values, what are the zeros, that's when you set equal to 0 and solve. So we're going to just do some examples here. We're going to do a bunch of examples. When you have a question like this, it says write the complete linear factors, then state the zeros. We're going to do it in 3 ways. We're going to factor over the reals. We're going to then completely factor. And then we're going to state the zeros, meaning we're going to say what x equals, okay? One extra step. So if you have a question like this, guys, I told you factoring is never going anywhere. All right? The first thing we're going to do is try to factor. What do you notice about number 1? There's a what? There's a GCF. What can I take out of all 4 of these terms? X. So I'm left with x to the third plus 3x squared minus 13x minus 15 equals 0, right? All right, now that I have 4 terms left, what would be the easiest thing to do? Let's try and group. Don't write this down. Let's try and group. What would I take out of the first set of parentheses? X squared. I'd be left with x plus what? 3. Could I take anything out of negative 13 and negative 15 that's going to leave me with x plus 3? No. Do we know another way to factor? Yep, P over Q. Very good. Does anybody want to remind me what P over Q is?
Plus or minus the square root of b squared.
No, not quadratic formula. What's our P over Q? Where do I look?
P is like the factors of the constant.
P is your constant, right? We're going to say P over Q. So I'm going to take the factors of 15. 1, 3, 5, and 15, right? So I have, let's try 1. I know. What's one of the zeros I already know I have? X equals what?
0.
Okay, I already know x equals 0. That's one of my answers. How many answers should I have total?
3.
How many total? 4. Okay, so if I'm going to try P over Q, I'm going to try 1. So I have 1, 3, negative 13, negative 15. Our synthetic division, right? Bring down our 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is negative 13, and 4 is negative 9. Is this going to work? Okay, let's try negative 1. 1, 3, negative 13, negative 15. 1 times negative 1, negative 1. 3 and negative 1 is 2. 2 and negative 1 is
2.
negative 2. Negative 13 and negative 2 is negative 15. Negative 15 and negative 1 is 15. Negative 15 and 15 is?
0.
Oh, does this one work? Yes, so x equals negative 1. Good. What do I do with this leftover? What do I do with 1, 2, and negative 15? What does that tell me? X squared
minus 2
plus 2x
minus 15.
minus 15 equals what?
0.
Can I factor this?
Yeah.
What times what gives me a negative 15 when I multiply and a positive 3 when positive 2, I'm sorry, when I add?
X plus 5, X minus 3.
X plus 5 and x minus 3. So what are my other two zeros? X equals
Negative 5.
negative 5 and x equals positive 3. All right, you guys told me what my zeros are. Okay, I'm going to write them over here so we can see it. X equals 0, x equals negative 1, then I got negative 5, and I have x equals what? 3, right? That's you guys solving it. You told me what the intercepts or the zeros are. If you are going to factor this over the reals, first of all 4 of these solutions real? Yes. How would you write them as a product of linear factors? That means I want parentheses. Tell me.
X minus 0, X plus 1.
X minus 0, agreed.
X plus 1.
Where'd you get plus 1?
Because it's a negative. So
Good.
it's a negative.
Very good. Then what?
X plus 5.
X plus 5 and
X minus 3.
x minus 3 equals 0. Now, how did we come up with those numbers, right? These are my zeros. These are my x equals. These are your zeros. This is factored over the reals. This is also factored how? Is this factored completely?
No.
Yeah, it's factored completely. Can you break any of those parentheses down anymore? Remember, when you factor over the reals, if you have imaginaries, you leave them as x squared plus something. Completely factored means you break everything down. Well, you'll see this a little better as we go through. But you have to be able to answer the question that is asked. The way that we got our answers, guys, does it have to be minus 0? Could it have been plus 0? Yes, doesn't matter. But you take, look, when I have x equals, you take this and you move it to the other side. You take this negative one and move it to the other side. When we take a negative number and move it to the other side of the equal sign, it becomes what?
Positive.
Positive. When I take this negative 5 and move it to the other side to put it in a parenthesis, it becomes
Positive.
positive. That's where we got x plus 5. When I take positive 3 and move it to the other side, it becomes negative 3. Does that make sense? All right, look at the next one. We're going to factor. I want to know what x equals. I have 4 terms. Do I have a GCF?
No.
No. So if I have 4 terms, should I group it?
You can try.
Yeah, I could try. But when I group the first 2, I can take out x squared and I'm left with x minus 7. But when I group the second 2, am I going to be left with x minus 7?
No.
No. So what do we have to do? P over Q. I look at the last number. It's 40. Ay, ay, ay. That's a lot of factors, huh? Plus minus 1. 2, 4, 5, 6, 7, 8, 10, 20, and 40. What should we start with? Just start with 1, see if it works. So I have 1, negative 7, 2, and 40. Bring down your 1. 1 times 1 is 1. Negative 7 and 1. Negative 6. Negative 6 and 1 is negative 6. 2 and negative 6 is negative 4. Is this going to work?
No.
Okay, go to negative 1. 1, negative 7, 2, and 40. 1 times negative 1 is negative 1. Negative 7 and negative 1 is negative 8, right? Negative 8, negative 1 is 8. 8 and 2 is this one going to work?
No.
Okay, let's go to 2. 1, negative 7, 2, and 40. Bring down the 1, so 1 times 2 is 2. Negative 7 and 2 is negative 5. Negative 5 and 2 is negative 10. 2 and negative 10 is negative 8. Negative 8 and 2. Is this going to work?
No.
Ay, ay, ay. Okay. Let's try negative 2. It's all right. It's good practice. All right. Bring down the 1. 1 times negative 2. Negative 2. Negative 7 and negative 2. Negative 9. Negative 9 and negative 2. Positive. All right. What's 2 and 18? 20. What's 2 times negative 2? Woohoo! What's 40 and negative 40? 0. So what'd you guys just show me?
This one is.
This one works. X equals negative 2, correct? Okay, so what do I do with this leftover?
You make it x squared minus 9x plus 20.
It is perfectly, yes, x squared minus 9x plus 20 equals 0. Now, we could do P over Q again, or you could figure out the factors of positive 20 that multiply to give you positive 20, but add to give you a negative 9. What are they?
Negative 5, negative 4.
X minus 5, x minus 4. Good job, guys. So what are my two other x values? X equals 5 and x equals 4. So I'm going to write over here x equals 5, x equals 4. Okay? What are these? These are my what? They're my x's. Those are my zeros. Those are my solutions. Those are my roots. What do you notice about all three of these roots? They are all what?
Real.
They're all real. So when we leave it factored over the reals and factored completely, it's the same thing. What are my three parentheses? What do they look like?
X plus 2, x minus 5, x plus 2, x minus 5,
and x minus 4. That is completely factored, and that's also factored over the reals because all three of them are what kind of answers? Real. Does that make sense? Do you guys understand the difference of what they're asking you?
Wait, so you don't have to put the 0.
All sorts of factoring. You guys are going to see all sorts of factoring. So let's look at this. All right. We're finding the zeros. We're finding the completely factored form, factoring over the reals, factoring over whatever. We're factoring. So I look at this and I say, okay, is there a GCF? No. Can I do A times C?
Yeah.
I can. If you guys didn't see that, what else could you do?
P over Q.
P over Q. You do the factors of 6, 1, 2, 3, and 6. But when you do your synthetic division, what do you have to look out for?
0.
Right? There's a place for x to the 4th, but is there a place for x cubed?
No.
No. There's a place for x squared, but is there a place for just x?
No.
No, so you got to put in your gaps. But you can factor this, guys. This is 1, and this is 6. What are the factors of 6? That'll multiply to give me 6, but add to give me 7. 1 and 6. 1 and 6, right? Well, what times what gives me x to the 4th? X squared and x squared.
Wouldn't it be minus 1 and minus 6?
No, because we want a positive 6 when we multiply, but a positive 7 when we add. So positive 1 and positive 6 will give me a positive 6 when I multiply, but a positive 7 when I add.
I was thinking of that.
That's okay. That's right. Now, we're going to answer this question. We're going to factor over the reals. We're going to factor completely. And I want to know what the zeros are, what x equals. What do you know about x squared plus 1 and x squared plus 6?
They're imaginary.
They're both imaginary, right? So if you factor over the reals, your answer would be x squared plus 1 and x squared plus 6. Because do you have any real solutions here? No. If I factor completely, you guys don't have to do that at this step. You can find your zeros first and then factor completely if you'd like to. If you find your zeros, what do you do to each parenthesis? You set it equal to 0. So x plus 1 equals 0, and x squared plus 6 equals 0. So when you move 1 over, this becomes x squared equals negative 1, correct? What do you do to get x all by itself? You take the square root. So x equals what here?
I.
No.
Plus minus.
Thank you, sir. Plus, minus. There's 2 there.
Oh.
What about here?
You subtract 6.
X squared equals negative 6. Now what?
Square root.
Square root. What does x equal?
Plus or minus.
Plus or minus. Whoops.
I
Root 6. Okay, so those are your zeros. Your zeros are x equals plus minus I, and x equals plus minus I root 6. Right? You guys with me?
Yeah.
Now, if we're going to factor completely, that means I want everything broken down as much as possible. So if you need to write it out like this, that's fine. X equals I, x equals negative I, right? This one is x equals I root 6, and x equals negative I root 6. If you're going to factor completely, you're going to go backwards. You're going to put them in parentheses. What do your parentheses look like? If I move this I over here, what does it become? X minus I. If I move this I over here, what does it become? X plus I. If I move this I root 6 over here, what does it become? X minus I root 6. And if I move this I root 6 here, what does it become? X plus I root 6. Do you guys see that? It's one extra step. This is factored completely. It's much easier. I know it seems like, oh, it's so silly. I would write it out just like I did here and draw yourself a little arrow. It's much easier to see if you guys do that. Because on your test, I'm going to ask you to factor over the reals, to factor completely. I might ask you to factor completely and then tell me what the zeros are. I might ask you to factor over the reals and then tell me what the zeros are. So you might have some imaginary, some real. You know, like you have to be able to discern what the question is asking. You can't just do it all and then just be like, see, I did it. You have to answer the specific question that is asked, okay? Everybody understand that? If you just do everything, I'm not going to give you credit for it. You have to answer the question that is asked. Let's look at this last one. GCF?
No.
No? Okay. There's 4 terms. Can I group?
Yeah, try.
Okay, let's try and group it. See what happens. What can I take out of the first parenthesis?
X squared.
X squared, and I'm left with what?
X minus 3.
X minus 3. Okay. What can I take out of the second one?
Negative 2.
Negative 2, and I'm left with
X minus 3.
X minus 3. All right. What's my new GCF?
X minus 3.
X minus 3. So then what?
X squared minus 2.
X squared minus 2 equals 0. Okay, so if you were asked to factor completely, do you have any imaginary solutions here?
No.
No. Mm-mm.
This is X squared minus 2. Right?
It's a gross solution, but it's not imaginary. So if you find the zeros first, that's always the easiest, is to find the zeros first. So x minus 3 equals 0, x squared minus 2 equals 0. So x equals 3, and x equals what? You guys do it in your head? Plus or minus square root of 2. Right? You move 2 over, take the square root. So if you're going to write your 3 parentheses, factor over the reals, it's also factored completely. What would they be?
X minus 3.
X minus 3,
X plus the square root.
x plus the square root of 2, and x minus the square root of 2. Good. Very good. All right, let's do one more. Let me just make one up and then we'll be done. All right, write this problem down. One more. Write this one down. We're going to answer all the questions. We're going to factor over the reals. We're going to factor completely. And we're going to find the zeros. A lot of the times, guys, it's easiest to find the zeros and then work backwards to the other answers. But if you look at this example, all right, I have how many terms? 4. All right, we should always try and group. If you don't see that you can group or, whatever, you can do P over Q. It'll take you a little bit of time, but that's fine. But if I group these, what happens?
X squared.
I can take out x squared, and I'm left with what?
X minus 3.
X minus 3. In the second parenthesis, what can I take out?
4.
What kind of 4?
Positive.
I'm going to take out a positive 4, and I'm left with
X minus
x minus 3. Does everybody see that? The new GCF is what?
X squared plus 4 and then the X minus.
So I have x minus 3 one time, and then I have my x squared plus 4 equals 0. Agreed?
Yes.
What do you see in your solutions already? What can you see?
An imaginary.
I see imaginary and I see real. So let's go ahead and solve. Let's find out what x equals, and then we'll work backwards of writing our answer. So here I'm going to say x minus 3 equals 0. And here I'm going to say x squared plus 4 equals 0. So in this case, I have x equals 3. In this case, I have x squared equals negative 4. We take the square root, and we get x equals plus or minus what?
2i.
2i. So if I'm going to answer the question of what are the zeros, you guys would tell me x equals 3 and x equals plus minus 2i. You could also say x equals 2i, x equals negative 2i. Now, if I ask you to factor over the reals, what does that mean? What kind of an answer do I want to have? I want my parentheses, good. And in those parentheses, do I want any i's?
No.
No. Think about that, guys. You're confused about how they're asking that. They're asking you to factor over the reals. That means you don't want any i's in your answer. So if I factor over the reals, what do my two parentheses look like? X minus 3. And then what's the other one look like? So I don't have any i's in it.
X squared.
Perfect. X squared what? Plus 4. Good job, guys. Now if I want it factored completely, hold on, hang on, let me write the word. You guys know what I mean? Factored completely, what does it look like? X minus 3,
X plus 2i.
x plus 2i, and
Minus 2i.
x minus 2i. Fantastic. Good job, guys. Very good.